Is my okay? Once my screen starts, let me share my screen. Is my screen is visible? Let me know.
Yes, Yashwant, I can see it.
Very good. See, there is a folder. First of all, you need to create whatever the things I'm showing here in my desktop or else in my screen. Okay, those the same things you need to set up in a cloud. Assume that this is a cloud, not a desktop or not a local one. Assume that there is a folder in cloud. In cloud again, you can create such folders in tables, right? In you, if you know this one in Google Cloud, let me log into the Google Cloud console.cloud.google. Okay. Hmm. Yeah. So here, if you can see, there is a concept called BigQuery. Okay. In this BigQuery, you can store. Okay. I don't have access now because I was not subscribed. Okay. You here you can actually store tables. The example of the example tables you can see how exactly the folders, tables, and all. Similarly, I just created here one table. Let us consider is dataset table. Second is notebooks. Third is results. Fourth is requirements. What are the libraries that I require? Anyway, I did not add it, but you should add in the real time. And then one Python file that is called trigger file. Any name you can name, but I usually give it as a trigger. If you trigger this, everything will get automated. Got it? That is the concept. Okay. So now see the data set. In the data set, I'm having two folders. One is training data set. Another one is called validation data set. Okay. So training data set, if I click for data training and testing, both is trained data set only. Validation is the real unseen data, real data. Let us consider that is real data. This is historical data. Historical data only we need to feature engineer and then divide the train and test and then apply machine learning on train and then build the model, apply test on validation. That's it. One model is building. After that, you have to apply that model knowledge on the real time data, right? Unseen data. Then you will get the real results. So that is what validation. Validation result, validation data set. That is what the validation data set. This is the training data set. You need to create like this a training data set. Up to here, it is clear. Up to here, can I get a quick confirmation? Up to here, machine learning one project. Here, data set is there, and then uh, inside the data set, we
Yes.
just had, yeah,
Yeah.
very good. We just had, uh, you know, the
Mhm.
data inside the data set. There is training data set and validation data set. Fine. Then,
Yeah.
then you can create one more thing that is called. So let me again go to that. Yeah. And inside that again you can create one more folder that is called notebooks. Every notebook is its own thing. Let me remove these output files first because it should come automatically. Okay, so for example EDA, let me open and show you Visual Studios. In Visual Studios I build it. Aipochin Baba. Okay, so here you can see this is what the data set. Okay, and then data set I just explained training data set and validation and notebooks. In notebooks, first notebook is EDA. Okay, EDA notebook. So this will do all the EDA stuff. Let me remove this kernel. You can see all the EDA step, all the libraries at one time and reading the data set and then all the EDA things. And I'm storing the figure. This figure I'm printing out. I'm storing this figure in some location. That is what the results location. And with the name. Okay, this is called target distribution plot. I'm storing such results in there. Okay, you understanding me, right? So now again next one is called feature engineering notebook. This feature engineering notebook will do what it will do. Again, it will consider the same data set and then do the feature engineering. Feature engineering means what? Removing the null values and then impute them with proper value, and then removing the outliers, and all the categorical value to the numerical values. After that, uh, construct select the features. After that, divide the features into train data and test data. Got it? After I divide the test data and train data, those train data and test data, again I saved it in results. If you see the results, EDA results are all these. Feature engineering results are what? Training data and testing data. X train and Y train goes to the training data. X test and Y test goes to the testing data. This is an output of feature engineering. After that, machine learning. Again, one more notebook you should consider. There, if you see all the machine learning part, here the input data set is not the historical data. We anyway done the feature engineering. That particular path again here I have to pass to read the training X, training Y, testing X, testing Y. Then if you can see all the different models at once, I consider all the different models. I just consider the loss function, then training evaluation. So at the end, what I get is this one. If I use logistic regression, this is the precision, this is the recall, this is the F1 score, this is accuracy, this is the log loss. Decision tree, then these are the values. And if I use k-nearest, these are the values. If I use SVC, means support vector classifier, these are the values. Once you get this you should save it as a CSV. Okay, you should save it as a CSV to again results section. Then now the results of ML without ensembling. Again with ensembling techniques, right? We already discussed about ensembling techniques. Ensembling techniques. Now we take out the again X train, Y train, and we now consider the ensembling models also, like gradient boosting, XG boosting, random forest classifier. This is a bagging technique. Yeah, we consider that. Again, we do the same iteration, one by one iteration, and then we again come up with a very nice structured, uh, you know, outcomes. Everything. Now you need to decide which one is really good. Random forest is really good, or else XG boost is really good. Okay, gradient boosting is really good. You need to decide later on. Okay, and then we have to store all the values again in the dedicated results folder. Once you do that, once you do all these things, then go ahead and trigger file. You just need to run the trigger file. That's it. You have to create a trigger file. And that trigger file, if you observe my screen carefully, now I just run the trigger file. Now it started the EDA process. Now it will execute the EDA. It will explain me with a bar. Okay. It just started the EDA process. It will take time actually
ఇక్కడికి
considering all. See, you can see it here. It is done. EDA is done.
లేదు అక్కడ ఎవరు లేరు
Now,
క్లోజ్ ఉండేది
now feature engineering. Okay. So now once feature engineering step
ఎవరు
is done, next machine learning. And then
అక్కడ
machine learning started and again completed. Now ensembling.
వెళ్ళాడా గొడవ
Ensembling
గారు
also notebook is now running, and now
రూమ్
storing
లోకి
all the dedicated.
వస్తామంటాడు
Now all
అడుగు
notebooks are completed and executed. We can go and check in the results section. All the files will get added. See, these are all the, let me show in the here. Okay. So now all the output folders, you can see output, underscore output, underscore output, underscore output. These are all just now added.
రేపు
Correct?
పొద్దున ఉందండి
And
ఇద్దరం
then this one machine learning in results, so not this results, ML results. Here results section, EDA results. These are all the plots, different plots I plotted. These plots I can show to the stakeholders and explain the story, what happened behind.
ఉన్నారా లైన్ లో ఉన్నారా
Okay. And explain the story. And then these are the feature engineering results, and these are the ML with ensembling, without ensembling. Okay, it all depend on the trigger file. But now let us try to understand what exactly the trigger file, how that coding happens.
అయితే వాడిని అడుగు ఏమైంది రా భయ్
It is
ఇన్నిసార్లు
really
అడగాల్సి
easy.
రావాల్సి వస్తుంది ఏమైంది
It is
కథ
really
అడుగు
easy. Uh, It is really easy. Just give me a second. Yeah. It is really easy to understand. See, first of all, we need to mention where exactly the files are. Okay. And then read them. Then what are the notebooks what we have? So we have 4 notebooks. Just give the paths in a dictionary, Python dictionary. Then where exactly you want to store the output files. Then use that path. Then read that path from the local directory, right? OS, local directory. And then this is the execution. Simple for loop. Running the for loop, take one, execute notebook is the function we can use. That's it. Where is the input path, where we have to store, what is the name of it, and then what are the parameters, then kernel type is Python 3. This is important. Add the kernel 3 is Python. That's it. The simple function will help you to run one by one, one by one, one by one. This is called automation. If you execute it in real time using Kubeflow and all, that is what MLOps is. Have you ever heard about that term MLOps? Anyone here? Hmm? Yeah, that is what MLOps. But in reality, if you are using any cloud, instead of mentioning the paths here statically, we need to mention the paths dynamically. We need to create a YAML file. That is the ultimate. That is if you create an YAML file and store all paths there, next time, if you want to try the same pipeline, if you want to run the same pipeline on different data set, then you just need to change the path. That's it. You need not to come to trigger file and change. Instead, you can create an YAML file. There you can change all the things. There you can mention all the algorithms, what you want to run. There you can change all the hyperparameters. That's it. Because next time, if you show these results, then your manager might have suggest you, for example, EDA results. They might have suggest you, don't use this plot. Instead, you can use instead of dependence, you use another column. Then how do you do again? You go to EDA notebook and make changes? No, you need to create a YAML file. There you need to mention which columns and which columns for that. Then automatically, if you run the trigger file, automatically those plots will get. Is that clear? Can I get a quick confirmation how exactly in reality it will work?
Yeah, yes, Yashwant.
Got the idea? So in reality,
Yeah.
if you get play, so let me stop recording.